last video we have discussed about the various components of the time series data sets. So in this video I am going to talk about detecting a trend or the trend component of a time series data set. So if you haven't watched the previous video, I highly recommend that you to watch that video, because without understanding about these components, it is quite difficult to comprehend what we are talking in here. So basically in this video I am going to show you how we can detect the dataset, whether the dataset have some kind of a trend. So in this video I am going to use a previous dataset that we have used. So in the particular dataset we have rainfall and temperature data from 2010 January to all the way to 2019 December. So total of 10-year data we have, a monthly data set we have. So in the last video we have plotted the trend line or the lowest line for the particular data set. So just to remind how it is done, I am going to plot the trend line for this example also. So first of all you have to establish a time series object. So we can call the TS function and the data set. So when you are creating a data set or the time series data set, make sure to filter the data that is relevant to your study, because in the original data set, which is weather data set, there are multiple columns. However, for this example I have dropped certain columns and kept only the rainfall millimeter value. So we have to specify the start date. So we know it starts from 2010 January to and it ends with 2019 December. So frequency is 12, since we are using a 12-month period. So first of all let's see how the data set is. So now you can see how the data is distributed over the years. And now let's draw the trend line. So now you can see the trend line. So before moving to the randomness check, first introduction about this randomness check of this data. So in statistics and time series data analysis, checking the randomness of data is very critical. So in R we conduct runs tests to check this randomness of the data. So for an example, in the stock market, run test of randomness is applied to know if the stock price of a particular company is behaving randomly or there is any pattern. So the randomness test actually has two-step procedure. So the step one is to set up a null and alternative hypothesis. And in null hypothesis, we assume that the distribution of the two continuous populations are the same. So even though for this example we are using a monthly data set, you can use annual, quarterly or monthly data, other type of frequency data set also. because it doesn't matter what is the frequency of the data set for this particular randomness test. So by looking at this trend line, we can't actually determine whether it has a specific statistically significant trend. So to conduct these randomness test runs, I am going to use the T-series library, because there are other libraries also available also in order to conduct these test runs. However, for this example, I am going to use this library T-series. So first import that library. And then you have to define the null hypothesis. So for that we can use this. So I have mentioned previously, when defining the null hypothesis, we assume that the distribution of the two continuous populations. So in this case, we have to divide our population into two sets. So for this, for numerical data, the reference value number to determine the runs in the data set relevant to the reference. So it can be divided by that. We can divide the entire population into two continuous population. So having said that, this reference value can be set as the mean, median, mode, or any other custom user defined value. So for this example, to divide the population into two continuous populations, I am going to use the median. So in this case, we create a binary series from the numerical data by assigning number 1 to the values above the reference, which is the mode, and 0 to the values below the reference. So if you look at the data set now, you can see in the first 6 numbers, it has converted into the binary values. So this is the end of first step when calculating the randomness or analyzing the randomness of data. So in the second step, we conduct calculations of statistics including mean and variance of the particular data set. Therefore, when we call this runs test function, R automatically calculates these statistical components and output the p-value, or whether the result is statistically significant. So we can simply call runs.test So after conducting the runs test, we can evaluate the p-value. So in this case, p-value is greater than 0.05. Therefore, we can conclude that the data set is purely random and does not have a particular trend. So at the end, what I want to emphasize is that since if the p-value is less than 0.005, we reject the null hypothesis. However, in this case, p-value is greater than 0.5, which is around. Therefore, we stands with the null hypothesis, which denotes the random.